Okay, our next example for finding the center of mass in the area between two curves. It's going to be a version question 10, where we're looking at the two functions are y equals sine 2x and y equals sine of x. And the region for x's, or the range of x's, is 0 to pi upon 3. Now, if we take those two functions and we put them into Desmos, you get y equals the sine of 2x, looks something like this. And y equals sine x looks something like this. And that point there, very nicely, ends up being pi upon 3. So this is the range, the area, in which we are going to be calculating at the center of mass. So if I was dare I guess, you might be somewhere about here probably. So A is going to be the area between that shape, the integral from 0 to pi upon 3 of f of x subtract g of x dx. So it's going to be the integral from 0 to pi upon 3 of the sine of 2x subtract the sine of x. And when you integrate the sine of 2x, you get negative 1/2 cosine of 2x. And when you integrate negative sine x, you get plus cosine of x. And that's going to be evaluated at 0 and at pi upon 3. So what we have now is negative 1/2 cosine 2/3 pi plus cosine 1/3 pi. Take away 1/2 cosine of 0 plus cosine of 0. That's negative 1/2. That's 1. That guy, I believe, is 1/2. And this guy is negative 1/2. So you get negative 1/2, you get 1/2. So you put, no, sorry, 1/2 and another 1/2, so you get a quarter. So that's negative 1/2, that's negative 1/2 plus a quarter. You put all of those pieces together, what do you get? You get 1/4 plus 1/2, plus another 1/2, take away 1, and you get the answer that it's a quarter. It's kind of the first part of the puzzle done. A is 1/4. To get x bar, we do 1 over a, integral from 0 to pi upon 3, x times f of x, which is the sine of 2x. Take away sine of x dx. And since a is a quarter, 1 over a quarter gets you 4. And then we're going to do the integral from 0 to pi upon 3. And I'm going to split this up as an x sine 2x dx. Take away an integral from 0 to pi upon 3, x times sine of x. Both of those guys, both of those guys, you're going to have to calculate the area of them using integration by parts. So when you finish, you're going to have 4 times whatever that answer is, take away whatever that answer is. And you're going to get, eventually, 1/4 pi. Just looking up the answer here, so I don't have to do it. 1/4 pi, take away 3/8. So the whole thing ends up being pi, take away 3√3/2. So you can imagine there's a lot of work just to get to there. Fortunately, there is no symmetry in this shape. So we have to do the second one, which is going to be y bar. That's 1/a, integral from 0 to pi upon 3, 1/2 f of x squared, take away g of x squared dx. And that's going to be 4. Actually, I could bring that 2 out as well while we're at it. And if you take the first guy, you get sine squared 2x, take away sine squared 1x. And this time I'm going to use a trig identity. Sine squared can be written as 1/2 1 minus the cosine 4x. And sine squared can be written as 1/2 1 minus the cosine of 2x. So we have 2 integral from 0 to pi upon 3, and I'll bring this half out. And now I'm left with 1 take away the cosine of 4x, subtract 1 take away the cosine of 2x. So y bar ends up being the integral, because 2/2 is essentially 1. That fella, 1 take away the cosine of 4x, subtract 1, add the cosine 2x dx. The 1's cancel. We are left with a negative cosine 4x plus a positive cosine of 2x. Okay, integrate a cosine, you get positive sign, so negative 1/4 because of that, sine of 4x, plus 1/2 sine of 2x, evaluated at 0 and pi over 3. So it's going to be 1/4 the sine 4/3 pi plus 1/2 the sine 2/3 pi. And this eventually becomes 3√3/8. So x bar, y bar, the center of mass is pi. Take away that guy, and we are finished.